So this is a very common exam question and a very common reaction that you need to be able to explain. We're going to look at displacement reactions of the halogen. In these, you take the element, so either chlorine, bromine or iodine as the element, and you react it with a salt of the other one. So the key one is I'm going to take chlorine and I can react it with, say, sodium bromide. So that's the element and that's the salt. And we find that a more reactive halogen displaces a less reactive one from solution. We'll look at why chlorine is more reactive in a minute, but reactivity, can you remember from GCSE what happens to reactivity as you go down the group? As you go down to group 7, what happens to reactivity? Reactivity decreases as I go down the group. So, chlorine, we can say, is more reactive than bromine. So, chlorine comes along, kicks bromine out to make sodium chloride and bromine. So, let's have a think about that. Chlorine, I'm going to write as Cl2. Sodium bromide, what's going to be my formula of sodium bromide? NaBr, why NaBr? Yep, sodium's in group 1 so it form Na+, bromine's in group 7 so it forms Br-, so 1 plus 1 minus, to give me sodium chloride, NaCl plus bromine. And I need 2 there and 2 there. Now we generally do this in water, so I'm going to put aqueous. Next to each of those. So I take chlorine water, react it with sodium bromide dissolved in water, and I make sodium chloride and bromine. So, that is because chlorine, so if you think about it, sodium and bromine are nicely bonded together. Yeah, they're happily bonded together. Along comes chlorine, he's more reactive, and he kicks bromine out. He says, I want to become a chloride ion. I want those electrons. Does that make sense when we look at the redox, our oxidation numbers? Have you done oxidation numbers? Yeah, okay. So, what is the oxidation number of chlorine? Elemental chlorine? 0. Yeah.
We didn't do it that complicated.
Okay. Right.
We did basic.
Did you do, well, any element, the oxidation number is 0. What about a simple ion like Na+? The oxidation number is +1. For bromide rather, -1. It's just the charge on the ion.
Okay.
Yeah. What about Na+? +1. Chloride is -1, and bromine as an element is 0. So did you look, what's happened to chlorine? Chlorine's gone from 0 to -1. Did you look at this in terms of oxidation and reduction?
Yeah, we did that.
So 0 to -1, what's happened to my oxidation number? It's gone down, so it has been reduced. What's happened to bromine? Gone from -1 to 0, so he has been oxidized. So this is a redox reaction. So we now know this is a redox reaction. So in water, what colour is chlorine? Chlorine in water is pale green. What colour do you reckon sodium bromide is going to be? And sodium chloride. Sodium chloride, you know, that's table salt. What colour is salt in water? Colourless, isn't it? These are both colourless. What colour is bromine in water, according to our table? Orange. So bromine is orange. So what would I see in that reaction? I'd see it go from pale green to orange, like so. So what they'll often ask you is they'll ask you to do the equation and then state your observation. So in this case, I will see it go from pale green to orange. Okay, so that was chlorine with a bromide. What we'll do now is we'll do the next one, which is going to be chlorine with sodium iodide, and we'll be able to whiz through these more quickly now. That's going to give me sodium chloride plus iodine. How do I know that reaction will work? Well, iodine is lower in the group than chlorine, so chlorine is more reactive. Let's try and quickly do the symbols. Chlorine we know is Cl2, aqueous. Sodium iodide, Na, I gives me NaCl, aqueous. Don't forget my aqueous down, plus I2, aqueous. And let's have a couple of those guys in there as well. We can do our oxidation numbers as normal. What I want to do is I want to focus on the colour changes, because we've done them before. So let's go through colours. Chlorine we said was pale green. These two are going to be colourless again. What colour is iodine in water? Yep, according to it's a brown colour, so it's going to go brown. So my colour change in this example would be from pale green to brown. Those are my two chlorine ones. There's one more equation you need to know, and that's with bromine. And we'll talk about why we don't need to know any others in a minute. I'm going to do bromine plus sodium iodide. Can anybody hazard a guess as to what I'm going to make? Sodium bromide and of course iodine. Let's quickly whiz through our simple equations. Br2 aqueous plus NaI aqueous, and that's two of those. 2NaBr aqueous plus I2 aqueous. And we can do our colour change again. What colour is bromine in water? Orange. These two, as ever, are going to be colourless. Any salt of a group 1 metal is colourless. Iodine we set up there was brown in water, and therefore in this case I will see the reaction go from orange to brown. Why do I not need to do this reaction? Why don't I need to do iodine plus sodium chloride? Well, why is there no point doing that reaction?
Because chlorine doesn't change colour.
Well, if a reaction would, what can we say about the reactivity of iodine compared to chlorine? Iodine is less reactive than chlorine, so no reaction. So what would I see in this reaction? Iodine is brown in water, so what would happen? It would just stay brown, nothing would happen at all. So once you've done, because I've established this way that chlorine displaces iodine, this would just be the reverse, wouldn't it? So if I establish this one goes, I know that there's no point doing that one. So there's actually only 3 that you need to do to establish the reactivity. You need to do chlorine with bromide and iodide, and then you need to do bromine with iodide, and then you've established your order of reactivity.
So fluorine is the most reactive.
Fluorine's the most reactive, but we don't use fluorine, we don't need to worry about that. But chlorine, we're going to work in the lab, we work with chlorine, bromine and iodine. When we've done the first 2, we established that chlorine is more reactive than bromine and iodine. And then this one established that bromine is more reactive than iodine. So by doing those 3, I've established my reactivity down group 7.